In this video, we're going to look at section 2.6. Okay, this is where we are working with formulas, and we're going to look at a couple geometry applications as well. All right, so I want to do the top part of this, and then I want to do, about half of the problems on this sheet, and we'll save the other half for Monday. Just want this to be a quick intro, enough to where you can get started on your homework. Okay, so literal equations are equations that contain several variables. Okay. So you see down here, I have 3 literal equations, but those are also formulas because they have a specific application. If I wanted to create just a literal equation, I absolutely can just do things like x, y equals, x, y squared, z minus w, just throwing letters together that don't necessarily have any specific application is a literal equation. Okay. A formula is a literal equation that does have a specific application. I just put a couple of them down. Like the perimeter of a triangle, it's really like if you have a triangle, you know how they'd have 3 sides, A, B, and C. The perimeter would just be the length around the edge of the triangle, the distance all the way around the edge. So you would just add up A, B, and C, and that would give you the perimeter of the triangle. And then the second one I put down as an example is the formula for calculating simple interest. So this is kind of the type of interest that's used a lot of times on car loans. All right. And then I put the area of a circle. Okay. So those are examples of literal equations that are actually formulas. All right. Now, what we're going to wind up doing in this homework, is really 2 basic things. One of the things we're going to work number 1 together. One of the things will be like question number 1A, where they give you the formula. Okay, let me blow this up a little bit. Okay. All right. Where they give you the formula, and then they give you the values of all but one of the variables. So like on 1A, we're supposed to find P, but they tell us that L is 36 and that W is 21. So we just replace L with 36, replace W with 21, and we do the work that you see there. And you're now in the area where you're allowed to use calculators. So you can literally type all this in if you want and get the answer. I'm doing it without a calculator, so I'm going to be working it out. It's like 72 plus 42. Okay, so that would wind up being 114 when I do it. And this was just feet. So was that. So this is feet, that's feet. So the overall answer is just feet. Perimeter is actually a length measurement. Okay, so you see some of the problems you have in section 2.6 will be like that, where you replace some of the variables with numbers, and then you calculate the value of the remaining variable. Okay, so this exercise is kind of telling you why you're going to do this other thing. Okay, so part B has me use that formula. Let me write it here so it's right here in front of us. And this time they're telling me the perimeter is 235 inches and that the length is 77 inches. And my job is to figure out what W is. See, up on the part A, I was trying to figure out P. And P is already on a side by itself. So 1A is just like an order of operations question. It's just a numerical expression I have to simplify. But this one, B, is quite a bit harder. I would probably go ahead and multiply 2 times 77. So that'd be 154 inches. And then I would work on, I'll leave inches out so that we don't have it being so wordy. Okay. And then we're working on getting W by itself. So the next thing I would do would be to subtract 154 from both sides. When I do that, I would get 81. This is now gone. equals 2W. And then I'd have to divide by 2, and that would give me 40.5 inches, 40.5 inches. It's funny, when you're doing word problems, a lot of times you do prefer your answer to be in decimal form so that you can interpret it better. So you can see what is the length or what is the width really, okay? So your answer on A would have been that the perimeter turned out to be 114 feet. And you didn't really have a whole lot of rearranging to do because all the numbers were over here on the right. But on B, we actually had to solve. We didn't have to just simplify an expression. We had to solve the equation to try to unwrap, to try to undo what had been done to W. And after we did that, we found out that the width would need to be 40.5 inches. Okay. Now my next question is, which of those two problems was easier, took the least amount of work? And it's definitely A, because really I didn't have to do any work, because right here I just have a numerical expression that can simply be typed into my calculator. I can hit enter and boom, I have 114. Where on part B, I have to do a little more rearranging and all to figure out what W would turn out to be. Okay. All right. So now these right here are kind of like the first part of the homework for section 2.6, where you're just using the formula. You'll be given everything but one variable, the value for all the variables except one, and then your job will be to plug it in and just figure that out. But then there's another part that's going to be like this. This is what people find harder. Take the formula in general, and it'll tell you to rearrange it to solve it for a particular variable like W. Let me change to my blue pen, like W, okay? So if I'm trying to solve for W, circle the variable you're trying to solve for. Your job is going to be to get rid of everything that's on that side where the W is, okay? Now this can be pretty conceptually difficult, so I'm going to try to help us a little bit by rearranging the two sides of this equation. So if it doesn't matter, P equals 2L plus 2W is the same as me switching it and saying 2L plus 2W equals P. What I think students find easier is if the variable you're trying to have on a side by itself is on the left. Now, what's weird about this is I'm trying to undo what's been done to W, but I don't have numbers in place of these other two letters, but I need to treat them like I do. What I mean is, when we were up here on the one where I had plugged in numbers, do you notice that one of the first things I did was to subtract the 154 from both sides? You know, that came from this 2L part. I subtracted that from both sides. I'm actually going to do that here, but in general. All right, now when I do, the 2L on the left now will cancel, leaving me 2W. But then this P and this 2L, they're not numbers, so I can't get a number here. I'm going to just have this expression, P minus 2L left. Now your job is to solve for W, so circle that W. You're not done yet until that W is by itself. So see that 2 out in front? I need to get rid of it, so I'm going to divide by 2 everywhere. So that's going to give me, let me raise it up now, that's going to give me W equals P minus 2L, all of that over 2. All right, and watch your capitalization. So use capital letters when they do, use lowercase when they do. Because like in formula language, you know, a little b and a capital B don't mean the same thing, okay? I'm thinking about formulas for, say, volumes of things. If I wanted the volume of a cylinder, for instance, capital B a lot of times is used for the area of the base. And then like the height of the cylinder would be H, and that would be the volume. And then little b is used a lot of times for the length of a side. And so they don't necessarily have the same meaning. Okay, it doesn't matter the formula, but just watch it. You'll get problems wrong sometimes just because you didn't capitalize when you were supposed to. Right now on this problem, I'm asking you to use this new formula we created right here. You made up this new formula. It's really the same relationship as this formula. They are the same relationship. They both show the relationship between W and P. But watch. Now, since I wanted what W was, and I was given on that part B, I was given the P and the L. If I use this new formula I made, look at how it turns into a numerical problem. 2 times 77. It's like I'm not thinking about how to solve. I'm just plugging in and doing the arithmetic. And I wind up with the 40.5 without a lot of effort, without a lot of thinking. Okay. So I wanted to just talk a little bit about why we do this. This is what we do a lot of times in physics and in some of our science classes. I don't want to have to memorize 2 formulas. I don't want to have to memorize this formula and this one. But one of them is better. Like the P formula here is better when you know L and you know W, right? So the P formula is better. Let me go back up to the top. This formula right here is best for situations where you know the L and you know the W, because then all you're doing is simplifying, plugging into a calculator and simplifying a numerical expression, okay? Our new formula that we created, this one here, it's better when you know P and know L, because then after you plug those in, you have a numerical expression that just needs to be typed into the calculator and you're done. That's why you might want to do it. If I gave you 100 homework problems, and on every homework problem, I gave you the perimeter and I gave you the length, and I had given you this formula right here, that means you would have to do these steps right here, this solving process 100 times. You would get sick of it. And on your own, you would say, every single time I subtract twice the length, and then I divide by 2. And you would come up with this formula for yourself. Okay? So it's best to have the formula solved for W when you're given, when you know the P and the L and are looking for the W. Okay? All right, so that just tries to tell you a little bit of the motivation for why you want your formulas in a certain way. And, when you're taking a lot of your science classes, you don't want to have to memorize 3 formulas when really you only need to know one of them, and then you can rearrange them as you need to. Okay? All right, I'm going to skip that one for now, and I'll skip that one and go to, let's do number 4 here. 4 and 5. So on question number 4, we're being asked to take this general formula, A equals P times 1 plus Rn. We don't necessarily have to know what it's for. And we're trying to solve for n. All right, so you want to circle your variable that you're trying to get by itself. Sometimes it'll be in more than one spot, and you have to watch that. Okay? So what I'm going to do first is remove the parentheses like we do oftentimes. P times 1 would just be P. P times Rn would be PRN. P times R times N. Okay, keep the A there. You're solving for N, don't forget that. Solving for the N. Okay. So if N is what I'm solving for, I have something being added to it, and then I have stuff being multiplied to it. It's kind of like if this had been 10 equals, or let me say 20, pretend this were the equation. 20 equals 5 plus 10n, something like that. Say that's what you had. That's how you should kind of see this equation, is that the little n is the unknown. Everything else we got to move out of the way. Okay, so this right here has a similar structure to what I'm asking you to do. And you would probably have very little hesitation about what to do over here when the numbers are in there. Wouldn't you subtract 5 from both sides? Over here, P has that role. P would be that. So I'm going to subtract P from both sides of that equal sign, okay? What I'm going to be left with, though, is not a number. I'm going to be left with A minus P, and it is capital. Okay, on the right side, I got rid of the P, that first P, but I still have P, R, N. And I'm working on solving for N. So let me catch up with my numbers just so you get the sense of what we're doing. So see how there's multiplication between N and the rest of the stuff? Multiplication between N and the rest of the stuff that's with it. Don't you divide to get rid of that on both sides when there's numbers? You do the same thing here. I'm going to divide by PR on both sides. Okay, so these are multiplication between things. P is a factor on the top and bottom. I can knock it out. R is a factor on the top and bottom. I can knock it out. Okay, but I can't knock this P out over on the right-hand side because of that, or the left-hand side, I'm sorry, because of that minus sign. Okay, so little n turns out to be A capital minus P over PR. And that's what they'd want. Okay. All right, so you use it a lot in science. And then this one question right here, I need this when we hit chapter 3. This is the same concept. And if you're not working on that process of rearranging an equation, you're going to have a little trouble with this. So please really approach the chapter 2 material in the way I need you to. All right, so number 5 is asking me to take this, think of it like a formula, this formula, and work on getting the y by itself. You're not going to have a numerical answer. You're going to have a new formula. Okay, it's just that the x will be on the right-hand side at some point. Okay. All right, so here's the idea. Trying to get the y by itself. So I'm going to get rid of the 2x by subtracting it from both sides. That means I have just 3y left on the left-hand side. And on the right-hand side, these are not like terms. They don't both have x's on them. So basically, I have a negative 2x and a positive 12. You could write it 12 minus 2x, or you could write it negative 2x plus 12. It has the same meaning. All right, now remember, our job is to solve for y. So I'm going to have to get rid of that 3 that you see as well. So I'm going to divide by 3. And I'm really dividing this side by 3. And you could leave it there for this homework. But when we get to chapter 3, I'm going to want you to go ahead and distribute that to both terms. So I'm going to go ahead and have you do that now. So it would be y equals negative 2/3 x plus 4. And by the way, that's the same as if you had negative 2x over 3 plus 4, like that. Those say the same thing. Okay? So rearranging, solving for y. So they would take this right here. But when we get to chapter 3, you're going to want to be able to get it separated because this is going to turn out to graph as a line. And you got to learn how to graph these lines. And it'll turn out to be a line that looks something like this when you're finished. Crossing at 4 with a slope of negative 2/3. And we'll talk more about that when we get to chapter 3. Okay? All right, I want to just do one more. I don't like these videos to get too long. So let's take another problem and work on getting it solved for a particular variable. So let's take one like number 9. Okay. All right, so on this one, our job is to solve that formula for H. You don't need to know what the formulas would do. I just happen to know that that one is the formula for the volume of a cylinder with a radius of r and a height of h. Okay, but you didn't need to know that. All right, so what I recommend you do is rearrange the sides so that the unknown you're solving for is on the left. Circle it. That stays, and then everything else has to go. So you need to look at what operation is happening between those variables and h. And you see how it's all multiplication there. okay? So what we're going to do is we're going to come in and we're going to divide by pi so that that cancels, and divide by r squared so that cancels out. But if I do that to one side, I got to come over here and do that to the other side. Okay, so that's basically it. Now we know that h by itself equals capital V over pi r squared. And that's what they'd want you to have done. All right, so let me stop the video and get this thing posted.